So this is has been one of the most enduring mysteries of all times, and so we'll kind of look into it and see the possibility of this occurring or not. We will kind of go into the multiple aspects of it. Now, this is a very famous quote which says that two possibilities existing: either we are alone in the universe or we are not, and both are equally terrifying. Yeah. So just to give an idea of what the scale of the entire universe. On the leftmost, the top leftmost is the Earth. Now, Earth is part of the inner solar system, like which kind of includes planets from Mars to Mercury. Then there is the entire outer solar system, which will kind of go till Pluto and the Kuiper belt. Now, then this becomes part of our closest star system, like the neighboring stars clump together. So this kind of includes your Proxima Centauri and Alpha Centauri and all those. These is part of the entire Milky Way. Now, one knows that Earth is at the very end of the arms of the Milky Way, at the end of the one of the arms. Then all the neighboring Milky Ways kind of make neighboring galaxies make a local group. So the Andromeda is part of this cluster. Then this local group is part of a bigger supercluster, which we call a Laniakea supercluster. So Laniakea is a Hawaiian god for one of seas or something. Then these superclusters kind of when clumped together are called the local superclusters. So the local supercluster is kind of the biggest unit kind of currently in scientific terms in astronomy, and then this entire local superclusters, like when most of them are clumped together, is part of the observable universe. So on Earth, it's a very small scale. Now, to kind of give you a comparison. So say what if Earth is kind of scaled down to a size of a pinhead. Now a pinhead is like what 1.5 mm across. So we are making Earth around 10 billion times smaller. Now say the moon would be around 1.5 inches away at this scale. So still within the realm of the presentation. The sun would be around 49 feet away. Our Pluto would be now lying at 2000 feet. The Proxima Centauri, which is kind of our nearest star, would be around 4,000 kilometers away. To give you an idea, like the entire length of India is around 3,000 kilometers. So yeah, that was lying somewhere in Central Asia. Center of the Milky Way. So as one can see, we lie at the edges of it, would be around 25 million kilometers away. Now even Moon to Earth is around 3.8 lakh kilometers. And Andromeda, which is kind of nearest neighboring galaxy, would be around 2.4 billion kilometers away. So like further away from Saturn to Earth, which is around 1.4 billion kilometers. So even when the scales are so down, like around 10 billion times smaller, still the distances are vast. That kind of gives you the entire immensity of the universe and the possibility of multiple life forms and advanced civilizations kind of occurring inside them. Like we know nothing about it. Like we know less about our own solar system. Like whatever lies out there is something a complete mystery. We are just scratching the surface of the universe. In this, there came a scientist. Feel free to stop at any time and ask questions. Is the two galaxies, the Andromeda and Milky Way, going to collide? Yeah, they are going to collide into each other, but this will happen like billions of years in the future. Like something that we will have to be concerned about. And one has to understand, like when galaxies collide, there is a huge amount of vacuum in between planetary systems and stars. So it's not that planets should start colliding with one another, star systems will start colliding with one another. What will happen is some of the star systems from Milky Way will go into the star systems from Andromeda, and some of the star systems from Andromeda will go into the star systems of Milky Way. So it is just going to be exchange of star systems. So mostly there will be no collisions and destructions per se. Even if humanity exists at that point of time to observe this entire collision. Now, as we have seen the entire scale and size of the universe, now there came a scientist like Drake. So he was in NASA. Now, this is a kind of a probabilistic equation. It is kind of tells us what might be the probability of advanced extraterrestrial civilizations, occurring in the universe. So people, so it's like a discussion starter. It is not a kind of a accurate mathematical equation. It's a probabilistic equation. And many of the factors on the right hand side, so for example, say NE or FE or FI or FC and L are all assumptions. So, but this gives a very good starting point for, astrophysicists to, start looking and where to look for possible signs of life. Now, what does the equation say? On the left hand side is the number n. So n is the number of technologically advanced civilizations which you are trying to find out in the Milky Way galaxy. Now what n is equal to? N is equal to r. Now r is the rate of formation of stars in the galaxy. So at what rate stars are formed? So that is kind of known. Then we have the fraction fp. So what fraction of stars have planetary system? Because having planetary systems is not a common occurrence. So whenever a star is formed, the debris which is kind of, should have formed into a star, but it does not get formed and is left out, gets generally formed into planets. So this left out debris is again a probability. Like all stars do not have a planetary system. So that is important. If the stars have a planetary system, then the next question is, do they have an environment which is suitable for life? Do you guys know the Goldilocks zone? So Goldilocks zone is a zone in around a star where water in liquid form can exist for life to kind
which is known as a habitable zone.
Yes. So it can't be too hot. Now, for example, Venus, it is so hot on Venus that water in liquid form cannot exist. So again, life is not possible on Venus. I mean, again, as we kind of go further away from, like, after the asteroid belt between Mars and Jupiter, again, water cannot exist in liquid form. It is generally solid. However, there are exceptions to this rule. The planet, for it to be habitable, should be lying within the habitable zone or the Goldilocks zone. Even if the planet has water, there is a fraction which will say from those planets can life even evolve? Because again, for life to evolve, there is a perfect combination of geology, chemistry, and biology all has to occur at that same point in time. For something to evolve from no life altogether, it's a difficult process. Like evolution of your amino acids, your protein compounds, which will kind of make up into molecules of life. It's a very difficult process and a long process. You need the perfect combination of everything. Thankfully, Earth had it, but it does not mean that all planets with water will have it. Again, that's a fraction of planets which have water will actually even have life. Again, even if the planet has life, will that life evolve into something, a species which is intelligent? So that is again a fraction. Again, evolution of man has been a completely accidental event. You have to understand that in the entire history of Earth, like, man has been living for a very small fraction of its life. So evolution of an intelligent species is a very, very, very rare occurrence.
And how do we define that a life form is intelligent enough?
Very good question, like brilliant question. Now, even on Earth, okay, now when we say look at a dog or an elephant or a cat, and we say, or a bee, and we say that they are not intelligent, it is a very human trait to say only when someone does something like us, that thing is intelligent. So the very definition of intelligence is evolving. However, when we say intelligent, we will kind of go at a very general consensus and say species which we can, species which are self-conscious, which can, see themselves in a mirror and understand that they are, themselves. They can identify themselves. Species who can think and create things, create new items. Species who can, transmit knowledge. One has to understand, like, what has made humanity kind of intelligent is its ability to transmit knowledge across lifespans. A book, however, we will kind of got a very general consensus of intelligence, something who kind of invents and develops new things. Yeah. Then we come to the fraction of, from those intelligent life beings, they should be able to develop technology that releases signs of their existence into space. That means that those life forms should not only, invent proper modern technology, but they should survive until that point in time. For example, even in humankind history, there have been many instances where we would have become extinct at many points in time in the past, but we just survived, again due to sheer luck. So even if intelligent life evolves from that, you have to kind of develop into a civilization. In all these fractions, the only positive fraction being the length of the time that this civilization exists, which is the last factor, L. Say if a species exists for 1 million years, just for an example, like an intelligent species, then for for 1 million years it will be sending electromagnetic waves into space. That gives us enough time to detect it.